Hello and welcome back. In the last few videos we talked about how to factor a quadratic equation. We went over factoring simple trinomials in which the coefficient in front of the x squared is 1, and we went over factoring complex trinomials in which the coefficient in front of the x squared is not equal to 1. Now we're going to be going over another factoring technique called difference of squares. So difference of squares is normally going to be used when we're factoring a quadratic expression that does not have an x term. So in this case, for example, we have x squared minus 25. Remember that we said that a quadratic expression can include an x term but does not have to. So in this case, it does not include an x term, but it is still a quadratic expression or function. The main thing is that we have the x squared. That is what allows it to qualify as a quadratic function. So the formula for difference of squares, the formula that we're going to be using to factor this expression, is as follows. So it states that a squared minus b squared is a plus b times a minus b. So as long as the first term can be written as something squared and the second term can be written as something squared, we can apply the difference of squares formula. So x squared minus 25 can be rewritten as x squared minus 5 squared, because 5 squared is 5 times 5, which is 25. And I will put a similar kind of color coding on this expression. So we can rewrite this expression as x plus 5 times x minus 5 based on the formula that we established. So notice that the first term was already squared, so we did not have to change that at all. But the second term was not squared, but we realized that 5 squared is equal to 25, or we realized that the square root of 25 is 5. So that allowed us to rewrite 25 as 5 squared, and by doing that we had an expression where both of the terms were something squared. As another example, we have 4x squared minus 9. So we can rewrite the 4x squared as 2x squared, because 2 squared is 4, and we can rewrite the 9 as 3 squared. Once again, we have an expression where both of the terms are something squared. We can apply our difference of squares formula and we will get 2x plus 3 times 2x minus 3. So in this case, the a value is 2x and the b value is 3. In the last case, we had that the a value is x and the b value is 5. So please feel free to look that over to make sure you have a good understanding of how we apply the difference of squares formula. Just in case you're not convinced that the difference of squares formula works, we can actually solve this the way we would solve a normal trinomial. So for example, with x squared minus 25, what we could technically do is rewrite that as x squared plus 0x minus 25, because 0 times x is just 0, which would mean that x is not included. And then we can do the same thing we normally would do. So we need two numbers that add up to 0 and multiply to negative 25. In this case, those two numbers are 5 and negative 5. 5 plus negative 5 is 0, and 5 times negative 5 is negative 25. So our two numbers that add up to 0 and multiply to negative 25 are 5 and negative 5. That means we can rewrite this as x plus 5 times x minus 5. So notice that we used 5 and negative 5. And you'll notice that that is the exact same expression that we got from applying the difference of squares formula. So now I hope you have a better understanding of how to apply the difference of squares formula and how we can use it to factor quadratic equations that do not have an x term. In the next video we will be looking at how to use our factor methods to go from the standard form to the factored form of a quadratic function. The factored form of a quadratic equation will make it a lot easier for us to sketch a parabola and will show us the importance of these factoring methods. But for now, as always, thanks for watching.